Welcome back, everyone. Today, now our lesson is going to shift towards word problems. And what I'm going to focus and help you guys with today is how to find the structure of a word problem, an algebraic word problem. So this is not for every single word problem. Obviously, I couldn't go over every different example, but the vast majority of algebraic word problems all contain the same structure, okay? So that's what we're going to look for today. And here's pretty much what their structure actually becomes. A lot of times with these word problems, we find them in the sense of where we have a rate multiplied by our variable or our unknown. I'll touch on that in a minute. Plus what I'm going to call a flat fee, and that will be equal to our total, okay? Now, there are a couple things to keep in mind here. The flat fee, I use a fee because a lot of times mathematically they're talking about a one-time payment, okay? That's what we're talking about with a flat fee. It's paid one time. I'm going to talk about it in context of money, but a lot of times this could be something that is already computed, so something that's already done. So if you're talking about distance, maybe you're running a race, you already ran that distance, or maybe you covered that distance. If you're actually digging into the ground, you already dug under the ground so far and you're going further. They all become this flat fee, okay? And that flat fee, algebraically speaking, is something we call a constant, okay? So that's what we're really looking for with that flat fee. Those are the words that we're looking for. We're looking for that constant, okay? The variable, this is our unknown. So this is where we want to look at the question. So the question will tell us what our variable represents. A lot of times it's how many eggs to fill a basket or how many chickens were in this coop, okay? That question is what we're looking for, and that's our variable. And you'll see what I mean when we get into this example as well, okay? The rate, that's pretty simple. That's where you see words like per or of. Those are words you're looking for your rate, okay? So when we look for these things, we were talking about like per month, per year, per day. These are things that we look for when we look for a rate. And obviously the total is, what was the total? Okay? What is it? That's very simple, okay? So using that structure, we're going to identify how this equation is actually created, and then we'll just solve it from there, okay? So here we're talking about a gym membership. There's a $50 activation fee, $17 per month for the membership, and if you spend $356, and here we have to be with the question, how many months do you have the gym membership? What I like to start with is this variable right here, okay? And I like to be very intentional and predictable. So when I'm asking my question, how many months? I don't know that answer. That's my variable, and I'm going to represent it with a logical variable like m, okay? You could use x, y for every single one, but I'm going to use m here for months to be specific, okay? Couple variables you don't use o, okay? Don't use I, don't use l, okay? For obvious reasons, we don't want to use these three right here, okay? Also, it spells oil. That's fun. So we're going to talk about how many months. So I'm going to place that in my spot for my variable here. Okay, so I have that variable, how many months. Now I find the rate. Well, where did I find those words for the rate? What was the cost per month? It's right here, this $17. So therefore, that becomes a 17 times M or 17M. My flat fee, my one-time payment, that's my activation fee. That's right here. So that's a $50, and then ask yourself, is it positive or negative? Well, because you're paying it and you're writing the sum of these totals, it's actually going to be a positive 50. Okay? And then my total is, if I spend the total of $356, there's our equation. So we've created it. Now we just solve as always. This is just a two-step equation from here. 17m becomes 306. Divide both sides by 17. M equals 18. Algebraically, that's your solution. Now we have to answer the question. Okay? So the question then is, how many months do you have the membership? We're going to write in a full sentence. Because we're talking about you, I have the gym membership open for 18 months. I'm going to abbreviate months right there. And that is your solution. Okay? You want to always answer these questions in full sentences. Okay? So, using that structure, now I'm going to do one more with you. Okay? And this is still the same idea. We're just going to branch off of this. We're talking about an oil pipeline and it burst. Gas prices went up by $2.20 per gallon. A little key there, per gallon. If that afternoon you bought 10 gallons of gas for $53.90, we want to know what was the price per gallon before the pipeline burst. So our variable here, G, is going to be the cost per gallon prior to the burst. So we want to be very specific there. Now, this is a little bit more complex, but using our structure, we can actually create it. So there's my variable G. Now the rate here, it says gas prices went up by $2.20 per gallon. So this actually is what I'm looking for here, but I don't know what that rate actually is. So what happened to this was it went up by $2.20, meaning I added $2.20 to it. Okay? Now I also know that my total here is going to be equal to $53.90, but then what happened to this? So imagine the gas was just $1 and you added $2.20 to it. We would take that value and multiply it by 10 for the 10 gallons of gas we bought. Well, what would happen here? You see what happens? I'm going to group these together, and now it actually becomes using the distributive property. Okay? And then I can solve this as well. So I'm going to use order of operations here, reverse order of operations. Instead of distributive property, divide both sides by 10 to make it G plus 220 is equal to 539. And then I can subtract both sides by $2.20. Final solution, G equals, let's have our actual value here, G equals $3.19. So let's answer this question. The cost of gas before the pipeline burst was $3.19.